This is Hamilton's principle. If it is stationary, stationary means constant. Its variation delta I must be 0. I am writing here this delta I will be 0. From this concept, you can derive Lagrange's equation. So, and this integration LDT or this integral is known as action integral or action, and since it is stationary, delta I is equal to 0 for actual path of motion. Okay. So now we have find the technique of calculus of variation. Actually, this method is used to derive Lagrange, not only Lagrange's equation, but also you can solve many problems from this. Okay. So let's consider 2 points x1, x2 here. Between 2 points, there are infinite number paths are possible, and according to Hamilton's principle, for actual path of motion, this integral is constant and the variation of integral is 0. Okay. So this is the actual path, and other are slightly deviation from actual path. Okay. So let's consider that the function j is a function of y dot x. Okay. Instead of here actually taken a Lagrangian L dt. We can generalize it. I think integral j, which is integral x1 to x2 in space of tx, t1 x1, t2 x2, f dt, where f is a function of Lagrangian is a function of position coordinate q, q dot and v. Okay. So, and t, time, q dot and t. Q dot means v, velocity is time. You can take any function which has some coordinate. Let's say here y, its derivative y dot with respect to the variable. Here t, q dot means dq by dt. So it is x. So if j, so now j obviously is a function of y dot x. Y dot means here dy by dx. Okay. So we can derive this here actual formula. So we take y dot dy by dx and j is equal to this. This represents the actual path of motion. Okay. For any path which is actually deviating from here, we can define it through a parameter. Let's say this middle one is the actual path, which is your y of x. So other path, we can write y of x plus something, y of x plus something. It's fine. Let's say assign those another parameter alpha. Y x alpha means it represents all paths. When alpha is equal to 0, it becomes actual path. So we can define the set of paths as y x alpha such that y x alpha is equal to y x0, which is actual path, means yx, plus alpha into some function of x, let's say eta x. Actually, all curves pass through two endpoints, x1 and x2. So at the endpoints, this eta x must vanishes 0. And for actual path, alpha is 0. There are two conditions. We have written y x alpha is y x0 plus alpha eta x. Eta x such that it vanishes at x0 x1 and x0 x2. Okay. Now we go for this integral. Integral now becomes a function of alpha because f contains y x alpha and y dot contains x alpha. For actual path of motion, actually this is a constant and a derivative del j by del alpha is 0 is equal to 0. Alpha 0 represents actual path. So we have to take a derivative, then put alpha is equal to 0. We got it 0. Now if delta j, you can let's say del j by del alpha. How you write it? Means derivative of this term alpha, derivative with respect to alpha, integration with respect to x. X and alpha two independent parameters. So it is same result if we first take derivative with respect to alpha, then take integration, or first take integration, then take its derivative. That means this is same as if I take inside this integration alpha del f by del alpha. But f is a function of y dot x. You know if f is a function of x, y, z, then del f by del t means del x by del t. Suppose if the case, then what is del f by del t? We generate del f by del x into del x by del t plus del f by del y into del y by del t. Is not it? Hello?
Yes, sir.
Yes, yes.
Sir.
This is a function of and del z by del f by del z, del z by del t. So I can write like this. F is a function, what to tell, and its derivative is like del f by del y and del y by del alpha, del f by del y dot and del y dot by del alpha, del f by del x and del x by del alpha. But x and alpha are independent parameters, so its derivative, partial derivative is 0. If partial derivative 0, we got this equation dj by d alpha is equal to this, or y dot is equal to dy by dx. Now integrate this second term. Integrating y parts dx del f by del y dot and del y dot by del alpha. This is your first function. This is second. So according to y parts rule, derivative first function into integration of second minus derivative of first into integration of second whole integration. So first function del f by del y dot integration of second. This one integration derivative of first function integration of second. This is integration dx del y dot by alpha, but y dot is equal to nothing but dx by dy by dx. Here we have written also in the first line y dot is equal to dy by dx. So now in place of y dot you can write dy by dx alpha dy by dx. Alpha x are independent parameters, so I can interchange their order. So I can write it as d by dx of del y by del alpha. Okay. So that this can be written as integration x1 to x2 dx into d or sorry d by dx, write it, of I change the order. So del y by del alpha. Okay. So what is my result? Here dx d by dx. They will cancel. Only I have d of dy by d alpha. Its integration means we have only d of dy by d alpha. Integration give you del y by del alpha. Okay? Are you getting my point? Hello?
Yes, sir.
Then this integration become by substituting this dy by d alpha. Integration become this del y by del y dot del y by del alpha minus this. But at endpoints, you know all endpoints passes through same x1 and x2, and eta x is equal to 0. So because y x alpha I have y x alpha is equal to y x0 plus alpha eta x. At endpoints, eta x 0 means this term vanishes. So at endpoints, del y by del alpha is equal to 0. So this term vanishes. Only I get this minus term. Putting that, I got my final expression that this and del j by del alpha becomes this. Now I am multiplying with d alpha in both sides. D alpha and taking the condition that del j by del alpha is equal to 0 because I know that is 0, that the endpoint actual path, and for actual path del j by del alpha is equal to 0. So for actual path this is 0, that means this integral must vanishes. Otherwise left hand side is 0 and this term actually I can write del y. They are all independent coordinates. If this is true, then for left hand side 0, the integrand must be vanishes. Integrand vanishes means my condition is 0 already written there, d del f by del y minus d by dx del f by del 0. Okay. Okay, is it clear?
Yes,
Hello?
sir.
So now if you replace one coordinate by many coordinates, here I take only one single y. If I take there are many number of y's, y1, y2, yn, then this will be del f by del y dy dx of del f by del y dot is equal to 0. For I can take any value 1, 2, 3. 1, 2, 3 dot 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 any value. Now replace f by l, y by q, y dot by q dot, x by t. That means y dot here dy by dx, it now becomes dq by dt. If you substitute this, then my equation becomes del in place of l in yi, that is qi, del l by del qi minus d by x is t dt del l by del qi dot is equal to 0. This is nothing but your Lagrange's equation for I is equal to 1, 2, 3. Okay? Is not it? Hello? Hello? Are you getting my point?
Yes, sir.
Uh,
Yes, sir.
this is the method of deriving Lagrange's equation. Okay. All the written, you have to take a look on it. Okay, I am not. Derivation of Lagrange's equation, simply putting this we get. Okay. Next thing is some problems are asked from this section. Actually, show the shortest distance in a plane. Find the shortest distance between the 2 points in a plane using the principle of variation. We have 2 points is given, 1 and 2. Find the shortest distance between them. We know for shortest distance means for exact path actually, and the integration of f dx is equal to 0, means the variation. It is stationary or constant, so its variation is 0. Okay. So for each problem, we have to find the f. So what is this total path? I have a total path is given. Let's say consider simply this path, this one between 2 points. Let's say small a to b. Then I integrate over whole length. I get the total path. What is this? This is a line integral, small line. What in xy plane? So it has a x component and y component. We know d square is equal to dx square plus dy square. So ds is equal to dx square plus dy square. So ds square is the length of this. You obviously know length of this means we want to know the length. this one length. Actually, if you take a short path, it will look like a right angle triangle. And for like a right angle triangle, it's you know a square is equal to p square plus b square. Is not it? Hello?
Yes, sir.
Huh.
Sir, ಆದ್ರೆ
For right angle, h square is equal to p square plus b square. For h square is actually here ds, small length. So it is dx square plus dy square. ds is root over of this. Now taking common dx, actually root over dx square, if it get out, then it will dx. 1 plus dy by dx square. We take y dot is equal to dy by, so dx into 1 plus y dot square. This small length. So total length is nothing but integration of this from 1 to 2. It becomes our integral. So what is f? Here, if this is the integral, written like here, in del, leave the delta, integration of f dx. It is integration of here. So what is the f value? Comparing these two, we can write f is equal to how much?
1 plus y square
1
root over.
plus y dot square root over.
Root over. Yes. So now if it is minimum, then it will obey Lagrange's like equation. So actually I1 plus y dot square. So f is equal to 1 plus y dot square root over. So equation must be d by dx del f by del y dot minus del f by del y is equal to 0. So you calculate del f by del y, then del f by del y dot. Del f by f is this 1 plus y dot root over del f. There is no y, so del f by del y is 0. Del f by y dot is equal to half 1 plus y dot square to the power minus half into y dot, that is equal to y dot by 1 plus y dot square root over. So, if putting in this equation, Euler-Lagrange's equation, we get derivative of this term is 0. That means this term is a constant. So, y dot 1 by 1 square constant. Simplifying it, taking squaring both sides, we get y dot square is equal to constant c1 square into 1 plus y dot square. So, taking y dot square common from two terms, we found y dot is equal to c1 by square root of 1 minus c1 square. Okay. That, so it is another constant. Let's say a. Y dot means dy by dx. So dy by dx is equal to a. So what is y? Dy is equal to a dx. Y is equal to integration of this a integration to x plus a constant, another constant b. So that is, it is straight line. So shortest distance between 2 points is a straight line. But we take a curved surface, then it is known as geodesics, which we generally use in general circular relativity, because for space-time curvature we use this term geodesics. Okay. But in plane, the distance between 2 points is known as a straight line. Similarly, we have another problem, minimum surface of revolution. We have to revolve a curve at length around y-axis to get a surface. We find the curve for which the evolved surface has minimum surface area. This is the problem. So how you check? We have to take the surface area at one point, then integrate it. Whole surface area we have to check is minimum, then it satisfies this Euler-Lagrange's equation. Okay. So we form a surface by revolutioning this curve around y-axis. So it will look like this. If we rotate this curve, suppose around this is y-axis, both sides, so it will look like this. Rotate around. Okay, it is curve. Each part of curve, so it look same behavior. Now consider a strip here. If the distance we know it is x, then what will the area of this strip? Let's say at a x distance.
Y,
This is the ds. If it is x distance, then total perimeter of this curve will be 2 pi x. Okay, perimeter. If this area is ds, small angle, so 2 pi x ds. So total area of the surface is not a single curve, but actually a region between 2 points. So ds is the area of that point. Like that. In the first case, this is your ds. We have to rotate this ds about y-axis. Imagine that. We have only rotate this ds about the axis. So this point, it will look like this curve. ds rotate around this y-axis. So this type of shape. This is ds and this area is 2 pi x. But total area of surface area of that generated surface due to ds is 2 pi x ds. Now from this we get the exact result. So 2 pi x ds, we integrate it from 1 for total length surface area means 1 to 2 pi x ds. Ds we know dx square by d square root over what is dx 1 plus y dot square like straight line case. Then we found finally y is equal to this 2 pi x 1 plus y dot square root over dx. We know that if j is represent minimum or exact path of motion, then it must satisfy this equation. Comparing this, we can say what is the value of f? F is 2 pi x 1 plus y dot square root over. Okay. So take its derivative. F is this. And del f by del y is how much? Del f by del y dot is this 2 pi x dot this, and del f by del y again 0. Since it does not contain y, so del f by del y is equal to 0. So we got final equation derivative of this term is equal to 0. It means this is constant. Now we simplify it. If this is constant, then squaring both sides like previous case, you get this, and calculating y dot, we found y dot is equal to this. So what is y? Integrate it. If you integrate this term, actually it is cos a hyperbolic inverse x by a. So we found ax is equal to cos hyperbolic y minus b by a. It represents a catenary actually. Catenary means a hanging chain. If you in front of railway station, there are some chains hanging like this. They have not a definite means not symmetric, and they look like this, like here, not symmetric. Generally found in front of railway stations, particularly. Isn't it that are called catenary? Actually, shape is look like that catenary. Okay. Another famous problem comes, that is Brachistocon problem. That is minimum time of free fall. If somebody is falling freely, then we have to find the path for which time of fall is minimum. Uh, it is very lengthy calculation. I am just only showing the process. That time minimum means time is equal to distance by velocity. So ds is the distance and time is equal to ds by v. It should be minimum. T should be minimum. So integral 1 to 2 ds by v. But how you convert v to s? We have to use that a starting point total energy is potential, and the cost of potential energy actually it moves, and its kinetic energy gradually increases, potential energy gradually decreases. At certain point its total energy becomes potential. If its velocity is v, its kinetic energy is half mv square, and if it at the height of y, then potential energy mgy. So this mgy must be equal to half mv square at a particular point. So comparing this, we can calculate the v. V is equal to 2gi root over. So now our problem reduces to integration of ds by 2gi root over. You have to find the solution, which is very lengthy. So then it is not asked in our examinations. But these two problems sometimes I have to show that minimum surface of revolution and find the shortest path between 2 points. Okay? Is it clear? Hello? 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 Am I audible?
Yes, sir.
Any problem?
Yes, sir.
Is it okay or any problem? Okay. I did all the steps. I will send this. Last time I tell you to add me in your WhatsApp group, but you have not added. Is there any problem? Or
No, sir.
you have a WhatsApp group or not?
Yes, sir.
Yes, sir.
So please add me. Oh, my number is if you can note and add 9777. If someone note 9777 023. I am also writing in chat box. Please add me so that I can send my all materials. 9777 969 023. Okay. हाँ ठीक 9777 96023. Add me so that I can send all my materials. Huh? Okay, this one okay. Next actual what to go for Hamiltonian. Actually, our part 2 means your sixth paper, MPH-6. Basically, we details discuss about Hamiltonian formulation. But since you know had the word Hamilton first, what is Hamiltonian? Here in few slides, I will discuss what is actually Hamiltonian. We also discussed in the last class its form. Hamiltonian is just total energy actually, and its exact form is summed over Pj Qj dot minus L. We have shown in the last class. So it's Lagrangian is a function of Qj dot T, but Hamiltonian is a function of Qj Pj T. So all Qj dot must be replaced by Pj if you write somewhere in a Hamiltonian. So there are some like Lagrange's equation of motion. We have set of Hamilton's equation of motion. How it comes? The legendary transformation. It is in our sixth MPH-6. We will discuss that details. Actually, H is a function of Qj Pjt. So if you take variation dH, like F is a function of x, y, z, we
Yeah.
write dF is equal to del f by del x into dx, del f by del y and dy plus del f by del z into dz. Similarly, h is a function qj pj t. J varies from 1 to 3n minus k or f. So we can write dj is equal to del h by del qj dqj plus del h by del qj dpj plus del h by del t dt. Okay. Again, h is equal to sum over pj qj dot minus l. So now take variation of this h, or dh will be dpj into qj dot plus pj into dqj dot minus dl. Again, l is a function of qj dot t. So dl is equal to del l by del qj into dqj plus del l by del qj dot tqj dot plus del l by del t dt. But we have already got this expression Pj is equal to del L by del Qj dot. So in place of Pj, you can write del L by del Qj dot here. Del L by del Qj dot. So you see these two terms cancel, plus minus cancel. So we have only expression dPj Qj dot minus del L by del Qj dQj minus del L by del T. Three terms. But here also we have three terms, and compare these three. We found del H by del Qj into dQj here. But here in dQj multiplied minus del L by del Qj. So minus del L by del Qj is equal to del H by del Qj. Okay. Similarly, comparing coefficient of del Pj, del H by del Pj is equal to Qj dot. and del H by del T is equal to minus del L by del T. But minus del L by del Qj nothing but minus Pj dot del L by del Qj. So del H by del Pj is equal to, we want final these equations, three set of equations. Q dot is equal to del H by del Pj, Pj dot is equal to minus del H by del Qj, del H by del T is equal to del L by del T. This is Hamilton's canonical equation, which details we discussed in MPH-6. Okay. Only remember, like Lagrange's equation, there are set of Hamilton's equation obeying this formula. Q dot means derivative with respect to t. P dot means derivative with respect to t. dpj by dt. Okay. So there are, and pj dot is known as generalized momentum. We also last class discussed cyclic coordinate, which does not appear in the Lagrangian. If a coordinate is cyclic, then corresponding momentum is a conserved quantity. So if Qj is cyclic, Pj is a constant. So cyclic coordinate does not appear also in the Hamiltonian. There are few problems. If the dynamics of a particle is governed by this Lagrangian, then comment the nature of the motion. Lagrangian is half mx dot square minus half kx square minus k xx dot t. By using Lagrange's equation, we can find del L by del x is this one, del x dot del L by del x is this one. Adding, you find mx dot 0 means mass into acceleration force. Force is 0. It represents there is no force. Then we call it a free motion. Motion of a free particle. Then Lagrangian of a system is governed by this. Find the constant momentum. If Lagrangian is given, you have to find the conserved momentum from cyclic coordinate. Here, L does not contain phi. So phi is a cyclic coordinate and corresponding momentum is a conserved quantity. Please mute. Malathi, please mute yourself. So phi does not appear here. So P phi is a conserved quantity. Phi is cyclic. But P phi formula is P theta del L by del Q dot. So P phi del L by del phi dot. From here you can get this one. Okay. Then the Lagrangian of a system is governed by this, and find the cyclic coordinate in spherical polar coordinate. You know, in spherical coordinate, x z is equal to r cos theta, x r sin theta cos phi, y r sin theta sin phi. So taking this x square y square plus half z square, we found actually this one. So here phi is cyclic. Okay. This is about our next part is actually central force motion. Okay. So this is actually there are two fundamental motions of the universe. You know, one is rotation of planets around the sun. Another is in the elemental level rotation of electron around nucleus. What is the similarity between these two? Which force is responsible for this solar rotation of planets around the sun?
Centripetal force.
That force. What is the origin of that force? That force magnitude is equal to centripetal force, or it is rotating in circular?
Gravitational.
That is a gravitational force, and that gravitational force equal to centripetal force. And here, what is the force due to which electrons are revolving around the nucleus?
Electrostatic force.
Electrostatic. There are two charged particles. It is electrostatic, not nuclear force. It is electrostatic force. Yes. Two charged particles, nucleus with positive charge and negative charge. So what is the two force magnitude? You know, here for gravitational force, F is equal to how much?
M1 M2 G into M1 M2
G M1 M2
G M1 M2 by M1 M2 by R square.
Then for electrostatic, what is the force? magnitude.
1 by
A
4
into
pi
Q1
epsilon
Q2
0
square.
Q1 Q2 by r square.
That's K. Take Q1
Okay,
Q2
okay.
by
By r
R
square.
square.
R
R
square.
square.
Look, these two will look like same, similar kind. Here only mass, your charge. So origin of gravitational force is due to mass, and electrostatic force is due to charge. Another thing, how it varies with distance of separation, like 1 by r square in both the cases. Varies 1 by like 1 by r square. Hmm. And these two type of forces actually called central force, and it is always directed towards away from a fixed center, means sun. These planets are moving, and if you measure the force, the direction is always towards or away from the sun. Here also the force is directed towards the nucleus. That type of force is known as central force. Okay. For central force, you don't know. The force is said to be a central force if it is always directed towards or away from a fixed point called the center of force. And the magnitude of this force is a function of the distance from that fixed point. Here you see magnitude depends on mass. Two masses are fixed or two charges are fixed. On distance of separation. It is only a function of distance of separation. So mathematically central force can be written as a direction which is the point joining sun or earth or electron nucleus. So it is position of r cap and a function of r only. Okay. If we choose the origin of as the center of force, then we generally represent Fr is equal to r cap Fr. Central force can be written as the magnitude which is dependent on r and r cap. If this magnitude f of r is negative, then less than 0, we call force is an attractive force. If it is positive, then we call it a repulsive force or it is electrostatic force. Here, if there are two opposite charges, then sign will be minus. So we know minus sign means attractive. You know opposite charge attractive. If same charge, either both are plus or both are minus, then it is plus. So we know same charge repulsive. It also says if r greater than 0, it is repulsive. So gravitational is the attractive force and its actual magnitude is minus g m1 m2 by r square. Okay? Hello, are you getting my point?
Yes, sir.
Yes, sir.
Okay. Um, Again, another property was the central force is always parallel or anti-parallel to the position vector r cap. R cap either r cap or minus r cap. So it is either parallel or anti-parallel to the position vector. So if it is the case, then if we calculate r cross f means r cap fr. So same vector cross product 0. So r cross f is 0 means torque. So torque acting and a particle moving in central force is 0. Okay. So torque 0 means we know what is conserved. Angular momentum is a conserved quantity. For central force motion, angular momentum is a conserved quantity. Again, conservation of angular momentum means its direction is constant and its magnitude is also constant. Constant means both direction constant and magnitude constant. Angular momentum is r cross v. So r cross mv. That means r cross v always constant. So r, if you know r is the position vector, v if it is moving like this is the direction of v. R cross v is direction. R cross v means toward this direction. It is always constant. That means it constant means motion all occurs in a plane in 2 dimensions. The central force motion occurs in a plane. Is it clear? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
The central force problem generally is a two body problem. There are two things, one is center of force and another body is moving around it. whether it is sun planet or electron nucleus. So next our work is how to reduce this two body problem to one body problem for our study. So reduction of two body problem to one body problem. Let us consider a conservative system of two particular masses m1, m2. These are the masses given here. There is a center of mass between them, and you know the relation between this. If center of mass position vector r is equal to capital R, let's say center of mass position vector is summed over I, mi, ri by summed over I, mi. Means here m1 r1 plus m2 r2 by m. So here let's say the position vector of the origin m1, position vector of m1 is r1, position of m2 is r2, and center of mass is capital R. So r1 minus r2 is equal to r. You will see. So with respect to center of mass, this m1 is position vector. We can write r1 prime, m2 r2 prime. So r is basically a difference between r1 and r2. R is r1 minus r2. Okay. Similarly, you can say the difference between these 2 points r1 prime minus r2 prime. Now, how we reduce this two body problem to one body problem? Let's calculate the Lagrangian kinetic energy and potential energy of the system. We know there are two particles. Right? So total mass of the system will be m1 plus m2. Its kinetic energy actually depends on kinetic energy of center of mass plus kinetic energy with respect to center of mass. There is a basic formula that kinetic energy of any system, you have to remember, this is equal to kinetic energy of its center of mass plus kinetic energy of motion of about center of mass. That means kinetic of center of mass means center of mass contains all mass m1 plus m2 capital R dot square plus half m1 r1 prime dot square plus half m2 r2 prime dot square. So Lagrangian is equal to T minus V. Now in place of r1 prime r2 prime, we use R to solve. Center of mass is balanced about a body is balanced about its center of mass or center of gravity. That means what? Summed of mi ri is equal to 0. If suppose here is a large mass, here is a small mass, then center of mass always tilted towards large mass. Why? Because this mass into distance product will balance with this mass and this distance. So what I write? So it will only balance. So if it is a balancing point, this would be same. So m1 r1 prime plus m2 r2 prime is equal to 0. From this you can calculate r1 prime minus m2 by m1 r2 prime. Now what is r? Then r will be difference between these two, r1 prime minus r2 prime, which I can write like this, m2 plus here given there is a simple formula. So r2 prime is related with r like this. So now I can write r1 prime in terms of r like this. My aim is substitute this r1 prime and r2 prime through r here. I put the value of r1 prime, r2 prime. Then I got this expression in place of r1 prime this, r2 prime this. I find this is my expression half m1 and 2 r dot square plus half m1 by m1 plus m2 this. Okay, this is my expression. But this term is known as a reduced mass, mu. Mu is equal to this, which is called reduced mass. Why it is reduced mass? Because mu is less than both m1 and m2. For that reason, it is called reduced mass. And its definition is 1 by mu is equal to 1 by m1 plus 1 by m2. Okay. If you take LCM and calculate, we found mu is like this. So mu is named as reduced mass because it is less than both m1 and m2. Why? Putting this value mu here, we got kinetic energy nothing but T half m r dot square plus half mu r dot square. So Lagrangian is look like this. Again, using Lagrange's equation of motion in terms of capital R, we found d by dt del by del r dot minus del by del r is equal to 0. From here, we found r dot is a constant. Center of mass is either at rest or moves with constant velocity. So it does not affect the motion of the whole system. Again, writing the equation in terms of small r, we found this mu of r dot is equal to f of r. This equation represents the equation of motion of two particle system. But it is just like one particle. Mass m, acceleration is equal to force. But this mass is reduced mass. So only change when you two particle related to one particle, we have to change the mass by reduced mass. So Lagrangian will be half mv square minus half mu r dot square minus va. Okay. Hello?
Yes, sir.
Okay. Next we go for classification of orbit. If a mass is moving on the central force, we know force is equal to Fr. If it is a conservative, we know by definition conservative force is negative gradient of potential minus del V del R. If we assume both conservative central force, then force can be written like this. Now we have to write the Lagrangian in terms, because central force motion occurs in a plane. So we have to write Lagrangian in plane polar coordinate r theta. Or according to kinetic energy is equal to, we know generally half mv square, or in polar coordinate v square is equal to how much? Half m r dot square plus r square theta dot square. It's a two dimension. Dimension is equal to kinetic energy half m vx square plus vy square. Isn't it? We know x is equal to r cos theta, y is equal to r sin theta. Taking its dot derivative in dx by dt, dy by dt, then adding this we get this half m r dot square plus r square theta dot. Is it okay? Hello?
Yes, sir.
So adding this is simply expression. So this is the kinetic energy in polar coordinate minus Vr, because central force motion occurs in a plane. So now use the Lagrange's equation. Here we have two coordinates r theta. So Lagrange's equation in two coordinates, one in r, one in theta. Though theta is cyclic, phi theta is a conserved quantity, but we can calculate del L by del theta is 0, but del L by del theta non-zero. So d by dt del L by del L dot minus del L by del r. Del L by del r, if you take this one and del L r dot like this. So Lagrange's equation becomes this m r dot m r square theta plus del by del r is equal to 0. Theta dot is equal to angular momentum. We will calculate there. J is equal to how much? Del L by del theta dot, which is called angular momentum. And del L by del theta dot is how much? Here you see del L by del theta dot is equal to m r square, here 2 theta dot 2 have cancelled, so m r square theta dot. So angular momentum J is equal to m r square theta dot, which is a constant quantity. Because why constant? Theta is cyclic, so corresponding angular momentum is a constant quantity. Again, for central conservative force, negative gradient of potential is your force. So we got a equation like this. We accept, we have added extra term this one with acceleration. We know mass into acceleration is equal to force. But here is another extra term. So adding this in the right hand side, we can write m r dot mass into acceleration is like this. But mass into acceleration is a force, so we call it as the effective force. So for central force motion, actual force is the effective force, and actual force plus j square by mr cube. Is it clear?
Yes, sir.
This call is effective force or fictitious force. Fictitious means imaginary. So you know v dot square, r dot square, r square, theta dot square. Okay. This one. So f prime r, what to write? F r plus j square by mr cube. If you convert j to theta, you find nothing. It is nothing but mv square by r, means centripetal torque. No? Particularly centrifugal. Let's call it. But if we assume it conservative, then f prime r must be negative gradient of potential from v prime r. So from that you can calculate the effective potential will be Vr plus j square by 2mr square. V prime r is this. So Vr effective potential, which is responsible for effective force, is like this. So total energy we know kinetic energy plus potential energy. Potential is this. Kinetic energy are two terms, half mr square r square theta dot square like this. So this is nothing but half mr dot square plus v prime r. So here in central force motion, total body is moving with same kinetic energy plus potential energy is effective potential, means there is some effective force acts on it. This is effective force, this is effective potential. Then orbits under inverse square law of force. Actual motion of the planets around sun. And there are two cases actually. Suppose we throw a stone to some height, then it is fell down like this. Okay. Suppose we roll a ball on a surface, and then ball will go and stop here. Isn't it? So tell me, after some time, ball will motion stops. Uh, both the cases, tell me what happens here. Why this stone actually falls back? Hello? When we throw a stone to off, after covering certain distance, they falls back, changes its motion direction. What happens here? Hello?
Energy finish
V
you.
equal to 0. Velocity.
Velocity zero. Velocity zero means this is velocity. So energy is actually our total energy, kinetic energy plus potential energy. Isn't it? So V is in kinetic energy, half mv square. So V is 0. Small v. This is potential. So if V is 0, total energy becomes what?
Potential
Potential energy.
MGH.
Yes. Total energy becomes potential energy. Here also, when motion stops, total energy becomes potential. Removing it as a kinetic energy, when the motion stops, it becomes rest. Total energy is potential energy, kinetic energy is 0. So there are two cases when total energy becomes potential. Either a body becomes rest or it changes its direction of motion. When total energy becomes potential, a body either arrests or changes its direction of motion. Okay. So the point where actually motion direction changes, we call it turning point. You know, everywhere turning point of a map, with that. At that point, direction changes. Right? The direction where direction changes, we call turning point. So a turning point in mechanics, we use the turning point word when total energy is potential. So total energy to become potential means in motion changes the direction. It is turning point. Okay? Hello?
Yes, sir.
Yes,
So
sir.
at turning point, this term is zero. You know half m r dot square velocity zero. So half m r dot square zero. E is equal to only v prime r for central force motion. In general motion, E is equal to v. For central force motion, we call E is equal to v prime r is a turning point. So now, okay, orbits under inverse square law of force classification orbit. So now we plot the you know, planets are revolving around the sun. The actual force is due to gravitational force whose magnitude is minus g m1 m2 by r square. Let's say g m1 m2 are constant. I take k. So actually force is minus some constant by r square. From this, you can calculate the potential. Negative gradient of potential force will be minus kr because take its negative derivative. If here this, then minus del v by del r is how much? Minus minus plus for again k constant 1 by r derivative is minus 1 by r square. Isn't that it? So force is minus k by r square when potential is minus k by r. So if my potential is minus k by r, then fictitious potential becomes like this. Now I plot, let's say plot of k by r, 1 by r plot, you know, it look like this one. This is second term, j square by 1 by r square if you plot, look like this. If you add these two, this then plot will be like this. What is important thing here? We know that when total energy becomes it is potential energy curve. Total energy becomes potential, then body changes in direction of motion. Now we take total energy in many cases. One case it is greater than zero. E1 means E energy greater than zero. E2 is equal to zero. E3 less than zero. E4 minimum point. Less than zero obviously, but minimum. And check how it describes the motion. Okay. So tell me this one. When I take E1 energy greater than zero, any point here or here or here, I take it energy on axis. You see everywhere it crosses at one point. At one point, total energy becomes potential. What it means? When total energy becomes potential, what happens? Hello? Turning point. So if
Kinetic
it is
turning.
like this, it will be back. So for positive energy, motion is look like this. Uh, It it cannot penetrate this region. It has a it only comes from infinity. I can go back to infinity. That is the turning point. Similarly, this picture occurs up to e to 0. It also comes to 1 line. So some negative value, but certain negative it becomes 2 points. If we describe this figure, this is the case. Let's say this point is R1, E1. First case, E1 greater than 0. Okay. Magnifying this figure, I got this only. I am focusing on that part. You see, according to our figure, this is E prime curve. So this is half a matter square. So V prime. So particle can never come closer than R1. If this distance is R1, we assume, so particle come, it goes back like this. It cannot never come less than R1. Okay, so one point. Second point is R for R less than R1, V prime exceeds E1. If you see here, if the case, okay, what is V and what is E? Total energy, this one, and V.
Potential.
Total energy actually less than V prime, which is impossible. Total energy is kinetic energy plus potential energy. And here T plus V prime. If V prime is greater than T, you will be minus. If V is larger quantity and getting E, it will be subtract T. Uh, half mv square, half is a positive quantity, mass is a positive quantity. So obviously small v square, velocity square will be negative. But velocity square quantity, velocity square never become negative. So it is impossible. So it can go beyond that. On the other hand, there is no upper limit where it comes. So this motion is not bounded. If you plot the orbit, it look like this. It is not bounded. And the it has only one turning point. Okay, we know that. So the orbit will look like this, infinity to this. And this continues up to second case when total energy is 0. Roughly same picture. When the total energy is 0, it's same picture. But third case when it becomes more negative, E3, what happens? See, there are two turning points. If someone coming here, then it is again back to here. Again, this point, it will be back to here. Then the motion is, what is the case? Hello, for negative energy, there are two turning points.
Elliptical curve.
There are two turning points. Energy less than 0, or E3 less than 0. We have actually two turning points, R1 and R2. We can say this is R1. First one is R1. This is R2. Within these 2 points, the motion occurs. That means motion is bounded. And its special case is elliptic one. Motion is between 2 points. So actually, it's just like this. Motion is somewhat elliptical or look like this shape. Then fourth case, what happens? In fourth case, you see the minimum point. Means R1 increases, R2 decreases. And here both R1 R2 matches. Only one radius. So if it is elliptical, one radius means it becomes A becomes B. Circle. So minimum case is a single radius circle. Okay. Circular motion. If you see also, it is a centripetal acceleration. You got the fun formula. So minimum potential is minus kr plus g square m square. Its minimum value gives you circle. Its minimum means how you know the derivative will be 0. So equating its derivative 0, you can find the radius of the circle, which is j square by mk. There is angular momentum. So energy at that time is putting in place of r0, you got mk square by 2j square. It is circular motion. So we got four things. When energy greater than 0, it is a high parabola. Energy is equal to 0, it is parabola shape. Less than 0, ellipse. Minimum is circle. And this behavior is not only for sun planet system or 1 by r, force is 1 by r square, but force is valid for 1 by r to the power n, where n varies between 0 to 2. For all, same type of analysis comes. That is for positive energy high parabola equal to parabola less than ellipse, minimum circle. Okay? Hello?
Yes, sir.
Kepler's problem, actually this is also derived by Kepler. Mathematically, we have from classification orbit, pictorial we got this, but mathematically Kepler also derives same things. Then Kepler, he gives three laws. Kepler's law of planetary motion. First law is every planet move around the sun in an elliptical orbit with sun at one of its foci. Means for ellipse, two centers, two focus, so plural of focus is foci.
Okay.
Second law, the radius vector drawn from the sun to a planet sweeps out equal area in equal time interval. That is, the aerial velocity is constant. Okay. Hall law, you know, the square of the time period of revolution is directly proportional to cube root of semi-major axis of elliptical orbit, t square proportional to a cube. The three laws, actually, we can prove this deduction of Kepler's first law. It is slightly difficult, but I did all the steps here. You can check it. From energy, you can calculate its variation with T with R, then theta with R. D theta and d theta, because J is equal to m r square theta, which is a constant. So comparing the d here dt dr by this, d theta dr by this. Now comparing dr both cases, d theta. Okay, you get this equation d theta. Okay, this equation. I'm not going to details because all are given here. You only did the mathematics. Generally, in a question, long derivation are not asked. So integrating d theta, you get theta minus theta prime. Actually, this type of thing you get theta. Putting this solution, you get already done here mathematical expressions. 1 by r, we got this expression finally. 1 by r, this represents the equation of orbit. And comparing with the equation of conic section, what is known in Class-2, the 1 by r it represent a conic section. Then it will be C1 plus C cos theta minus theta, or this small e known as eccentricity. And depending on eccentricity, we know whether it is a circle, ellipse, parabola, hyperbola. So eccentricity is comparing these two. We can say root over of 1 plus 2 square e plus mk square. Okay. So if taking e greater than 0, if e greater than 0, this term greater than 0, 1 plus greater than 0 means small e greater than 1, which is hyperbola. If e is equal to 0, eccentricity is equal to 1, so it is parabola. If e is equal to negative, 1 minus something means less than 1, eccentricity is ellipse. If this is minus or minimum, okay, the eccentricity is 0, we got a circle. Same thing we got from our orbit analysis, a pictorially we got same thing. Mathematically also you can get the same thing. There are also other two Kepler's law. Second law, third law. If you want, you can check its proof. Second law is equal aerial velocity is constant. Actually, we know J is equal to m r square theta dot. If you put m is equal to half, m is a constant, half is a constant, so half r square theta dot is a constant. But half r square theta dot is nothing but half r into r theta d theta. Derivative of this, or dA by dt. If dA is this, then dA by dt is half r square d theta by dt. Since it is a constant, we call aerial velocity. It covers equal area in equal time. It is a constant. Okay. Kepler's second law. Third law, similarly, you can also derive r square proportional to tq using this eccentricity formula. Okay, t square proportional to aq. I am not going details here, but I am providing the materials. You can check the simple mathematics. I have done here all steps. Okay, so I think you can understand it from this. Okay. Then there is a vector special called Laplace-Runge length vector. It is another constant in central force motion, which actually come from this product P dot cross J. P dot is equal to force, Newton's second law. Force is equal to dP by dt. Force F r cap. R cap means r vector by r, and J is r cross P. Taking its cross product, you find a quantity which is a constant. That quantity is this P cross J minus mkr by r, which is not Laplace-Runge length vector, because using this vector in short steps you can derive the Kepler's first law. Because Since A is this, it depends on J. B cross J means perpendicular to J, so A dot J is equal to 0. Okay. Another thing is you can calculate A dot R like this. From these two comparing, you can actually derive the Kepler's law. One way to derive Kepler's law. Okay. But another thing we have in the syllabus, virial theorem, which is very important. Virial theorem. The virial theorem is an important theorem in celestial mechanics and astrophysics. The virial theorem concerns time average of various mechanical quantities, particularly how time average of kinetic energy and potential energy are related. Okay. This was given by first Clausius in 1870. Let us consider a system of particles with position vector Ri and applied force Fi. So we know from Newton's law, force is equal to dp by dt, Fi dpi dot. So let us introduce a quantity summed over I, pi, Ri, pi dot Ri, and take its derivative with respect to t. So d by dt of pi dot Ri means it is equal to pi into Ri dot plus pi dot Ri. A dot b derivative a derivative dot derivative b plus derivative a dot b. Okay. Then the first term pi Ri dot is equal to p mass into velocity mi into Ri dot. But velocity Ri dot same vector, so its multiplication will be Ri square, Ri dot square. So mi Ri dot square. But we know half mi Ri dot square is kinetic energy, so it is nothing but twice of kinetic energy. Again second term pi dot Ri, but pi is Fi, so it is Fi dot Ri. So finally we got d lambda by dt is equal to t plus summed over I Fi dot Ri. Is not it? Hello?
Yes, sir.
So now take time average. How you calculate average? So you suppose the average age of 10 students. How you take average? We add the age of 10 students and divide by total number of students. Not it? Average of age. Similarly, here time average we take. We divide total time and add over. If it is continuous, addition becomes integration. For discrete we take addition. If it continuous we take integration. Now I integrate all 0 to tau and divide total number or total time tau. Okay, this is average. For time average similarly, an average of this kinetic energy T average I take and we got average of this. Average of this quantity is average of this plus average of this. Okay, but average of left hand side is written like this: 1 by tau. If you integrate it lambda 0 to tau to t plus this. It is a periodic motion. Then we know tau is the time period. Motion repeats at tau. So whatever value at 0, it is same as value at time period tau. Okay, so if you put periodic motion, it becomes 0. Also, in case of non-periodic motion, tau will be very large. So actually, we neglect very motion stops means actually we assume that it come back to the initial position. In both the cases, we can set it as 0. Lambda tau is lambda 0, same value in both cases. That means left hand side is 0. So we got 2t bar is equal to sum of Fi Ri average. So what it means? T bar is equal to minus half of Fi Ri. 2t bar is equal to 0 means t bar is equal to minus. This is known as virial theorem, and because this RHS is called virial of Clausius. Okay. So it is important for central force motion. If F is negative gradient of potential, then we will have Fi minus Ri cap minus del V by del I Ri cap. So T average becomes minus half into this or del V Ri minus minus plus del V Ri by Ri cap. Or for a single particle only one distance r, we can write T bar is equal to half del V R by R. Okay. So if you take any system, if you know its V velocity, V potential energy, then you can write is average of kinetic energy which contain velocity term. So V, if V is A r to the power n plus 1, then del V by del R will be n plus 1 r to the power n. Okay, then this equation becomes n plus 1 by 2 V bar. Okay. That means for inverse square law of force, we see n is equal to minus 2, then T is equal to minus half V. Or for harmonic oscillator, we last class see A proportional to distance means r to the power 1. If it will be 1, then what will the formula? If n is equal to 1, then formula becomes what? T bar 1 plus 1 by 2 is how much? So
तीन
that
सर सौ करोड़
T bar is equal to V bar. For harmonic oscillator, average of kinetic energy is equal to average of potential energy. Okay.
तीन और सौ करोड़
Screen is not visible. Hello?
नो विजुअल सर
Yes, sir, visible.
तीनों
Visible, visible. Okay. Okay. So another one is your closed orbit. Bertrand's theorem, it was written in syllabus. When orbit is closed, we only see one thing, circular orbit. Not it, elliptical orbit. Two orbit actually we see for circular orbit, this potential should be have a minimum value, and orbit elliptical orbit total energy is negative. Okay. From that to actually we have got a condition. That condition is gives you Bertrand's theorem. I'm going to that because that the Bertrand's theorem also state that derivation is here, but it's not derivation is important. The only central forces that result in closed orbits for all bound particles are either inverse square law of force or Hooke's law. Hooke's law means a simple harmonic oscillator, force proportional to distance. Either force proportional to distance or force proportional to 1 by r square. In only both the two cases, we get closed orbit for all bound particles. That is Bertrand's theorem. It is actually some analytical proof here. It is not so important directly as mathematical we got. We use some mathematics, but use some analysis also. If you are interested, you can check this slide. But our important is the theorem. So all about the central force motion. Actually, 1 month syllabus is which was taught to MSc student in 1 month. It was teaching you in one class. So this is the problem. So I am unable to tell all these things or explain all these slides. Okay. So, but I will send all these slides to you. These are closed orbits. And these are written on syllabus. Another thing is small oscillation. Which was written in our syllabus. But if you have any doubt or anything, you can ask me. I have given my WhatsApp number. You can write a question in the group or personally you can ask me if you have any problem. Anyway, small oscillation slide is visible. Hello?
Yes, sir. Yes, sir,
Yes, sir.
visible.
Yes, sir.
Small oscillation means when amplitude of oscillation is very small. Actually, in all the cases here in a simple harmonic motion, we take amplitude is very small. So in small amplitude, you can approximate something. When theta is small, sin theta approaches as theta, cos theta approaches as 1. So all formula valid for small oscillations. And there are 2 points: stable and unstable equilibrium. Equilibrium means we already discussed the total force acting on that point is 0. Okay. So I force 0 means Force is negative gradient of potential. So potential is a constant. Constant means we can say it is maximum or minimum. Both the cases are comes under equilibrium. Potential is maximum or potential is minimum. When potential is maximum, we call it unstable in equilibrium. If potential is minimum, we call it stable equilibrium. Okay. Suppose simple harmonic oscillation, it is rest where slightly disturbed it. Here potential is actually zero, so slightly disturbed it executes simple motion. Suppose okay, a stone is on a mountain, you slightly disturb it, it will fall down, cannot come back to its original position again. It is unstable equilibrium. Okay. So for stable equilibrium, V is minimum. So how you check potential minimum? Actually, we know in differential that if second derivative is greater than 0, then we call it V is minimum. Okay, for stable equilibrium, del square V del y greater than 0. If unstable, del square V by del square x less than 0, then we call it unstable equilibrium maximum potential. Isn't it? Hello?
Yes,
Are you
yes.
getting me?
Yes, sir.
So when it is minimum, then you only execute simple harmonic motion or oscillation. So we are interested when potential is minimum. I mean del square V by del square x greater than 0. So formulation of the problem, we know force is negative gradient of potential. We take Qy as the coordinates, Q0, Q1, 2, 3. Formulation not the coordinate. And potential is the only function of coordinate. Then what we do, so when it is stable equilibrium, slightly disturbed, it executes simple harmonic motion, it is unstable. If you slightly disturbed, it fell down. So in equilibrium, if we assume Q0, then whatever change you add through a parameter eta I change. Equilibrium Q0, so Q1 will be eta 1, Qi eta 1. Okay, Qi is equal to Q0i equilibrium of each particle plus eta I. Is the change. So now potential can be written as potential is a function of position coordinate only. Now potential is a function of Q0 eta 0i plus eta I. You can expand it like the all at equilibrium point Taylor series expansion, then derivative with respect to coordinate at equilibrium point into the change. It has a Taylor series expansion. You can, if you remember, if you write x0 plus h, then you write actually f of x0 plus h del f by del x at x is equal to x0. Isn't it? Here actually h is eta I. So eta I v del v by del x0. The higher term half and del square f by del x square, x is equal to x0 is it. Okay? Hello? Hello? I think it is displayed mathematical Taylor series expansion. You also know in your class 3. Are you getting my point?
Yes, sir.
Yes, sir.
Now we can simplify it, but equilibrium, you know, best term plus this. If you said assume that like simple pendulum that equilibrium potential is 0, then we can write potential is nothing but this quadratic function or double derivative of position coordinate. We can write like this. Let's say assume it Vij. So half Vij eta I eta j. Similarly, you can also write kinetic energy. Kinetic energy is mass into velocity square. So I can write mass as Mij Qi dot Qj dot square. So it is Mij eta, or you can take it Tij, half Tij eta I dot eta j dot. Qi Qj means Q0i plus eta I. Q0i derivative 0, so eta I dot. Similarly, Qj 0 derivative 0, eta j dot. So kinetic energy and potential, actually this is not nothing but mass Tij. we can write like this. So Lagrangian is equal to T minus V, Tij minus Vij, eta eta j. Using Lagrange's equation, d by dt this equation, if putting this, you can get this expression. And this is actually simple harmonic motion expression. But solution is C as e to the power minus omega t. Okay. Putting this solution, we can write Vij minus Aj omega square 0. This is 0 means Vij minus omega square t into Aj 0. So V minus omega square t must be 0. V minus, if you open it like this, V as component Vij, Vij is it Tij, means 1 1 minus omega square T1 minus T2. So this is 0. Its solution, each omega gives you one kind of frequency or one mode of oscillation. How many number of mode of oscillations? That much omega. Okay. So it is a normal mode and normal frequency. Each mode is known as a normal mode, and this frequency omega is normal frequency. For one-dimensional motion, which is external in your examination, kinetic energy is half mx dot square, potential energy half kx square. So comparing this, we can take Tij or T matrix is M, V matrix is K. So this formula V minus omega square T 0 gives you K minus omega square M 0, or omega is equal to K by M root over. But V, what is V? It is, we found here del square V by, you see, V is equal to del square V by del Qi del Qj, or same in del Q square. This is important. So V is nothing but one dimensional problem. It is del square V by del x square at x equal to 0 stable equilibrium point. So putting this, we get the formula this omega is equal to this. It is very very important formula. Most of the problems are expressing on this formula. Is it clear? Only remember this. Okay? Is it clear or not? Here V, you know this formula omega is equal to K by M root over. But this K is comes from this del square V by del x square. Some potential will given and asked to find the frequency of oscillation. You can calculate. You take this second derivative. Hello?
Yes, sir.
This is a simple harmonic motion. There are also calculate the normal mode eigenvectors, which is quite difficult. I will written here the value. It's some example how to calculate triatomic molecule. Its potential energy given like this. Suppose this is the molecule. Potential energy means is lost like attachment spring half k x square. Half k x square means distance x2 minus x1. Its equilibrium distance is b. It extend only x2. Here extension is x1. So x2 minus x1 minus b square. Here x3 minus x2 minus b square. Okay. So from this potential energy, using our coordinate, analyze coordinate, you can write convert it to this. In terms of coordinate, is eta 2 eta 1 half k eta 2 minus eta 1 square plus half k eta 3 minus eta 2 square. If you omit this equilibrium distance, generally from directly you can say if you take eta 1 eta 2 eta 3, it's okay. This is our potential energy half k x square. So now you can construct the V tensor, V matrix. Eta 1 square, what is the coefficient of eta 1 square? It is V11. That is, we have a form half Vij, eta I, eta j. So if you compare, half cancel, so eta j, if ij 1, then it will be V11 will be k. V22 will be 2k, V33 k. Similarly, V12 and V21, but 12 and 21 will be same. Eta 2, eta 1. So when there are product term, just like eta 1, eta 2, eta 2, eta 3, then we divide by 2 and give it once at 1 2 case, another in 2 1 case. So here we get minus 2. We get minus 2 into k. 1 minus k at 1 2 place, 1 minus k as 2 1 place. Similarly, here it had to be minus 2k, 1 minus k at 2 3 place, another minus k at 3 2 place. Okay? Hello?
Yes, sir.
Yes, sir.
Matrix construction like this. Similarly, here it underscore. Generally, kinetic energy is very easy. It is only product of half mv square. So v1, v2, v3. Its coefficient is m. Capital M here, 2 or 3 m. Then you use this formula v minus omega square t is equal to 0 and solve this. Putting value, you can get the 3 values of omega, which are there. This will calculate. There are some problems you can do by yourself. The potential is given, how to take its double derivative, then take root 2 over, then it is frequency. Unit mass is given or divided in frequency. Okay. Some problems are given, is potential, then take its del square v by del x square. Find the equilibrium, stable equilibrium point you have to calculate. First, set del v by del x is equal to 0. Then find the point. Here actually del v by del x 0, del v by del x you find the point. Then check stable equilibrium point where del square v by del x square greater than 0. That point you take here, del square v by del x, that point is x0 by m root over. This is your omega. Okay. So, try by yourself this problem and tell me in the next class whether you get the answer or not. Okay. Basically, these are in our 1-2 unit in the MPH-2 paper. Okay. Any doubt? Okay, I will give all these materials. Please add in the group. Then, if you have any problem on this, then you can ask me either in group or personally. You can WhatsApp me. Okay. Hello.
Okay, sir.
Yes, sir.
So I think I will stop here. Okay. Okay. Bye. Then I think my MPS 6 class in on 12th September. Then I will see. In between you add me in the group. I will send all these materials. Then if you have any question, you ask me. Okay.
Yes, sir.
Okay. I am leaving. Okay. Thank you.
Thank you, sir.